Right. Okay, it is 10:30, so I'm gonna get started. That clock is a little bit slow. I'm going by my watch, which is synchronized to the atomic clock, so I know what time it is. All right. So let's go ahead and get started with the homework assignment that is due on the 10th, not today, but next Tuesday. Okay, so we'll start with the homework assignment that's due on Tuesday. There are a few questions, people have been asking, so I will try to address those questions the best I can today so that you guys can continue to work on it. All right, so these are the questions. So what I'm going to do is I will display the questions as if I'm taking the test. So this way it will show the question. Okay. So in this case, there's no clarification that really needs to be done because in this case the domain only has 3 elements and then the codomain has 4 elements. Okay, so those are the only elements inside the domain and the codomains. So with this one, I don't think there are any questions. Are there any questions about this one other than which one is the answer? Okay. Okay, so there are no questions then. Moving on to the next one. Okay, this one is the same thing. I clearly state what is the domain and what is the codomain. Okay, so there's no implied or implicit domain and codomain. So we're going to move on to the next one because I want to get to the question that you were asking a little bit earlier. Okay, this one is in the HTML editor space, which is the space that's right below that. Define an injective and surjective function. Define the domain and the codomain and the function. So you can do it in a variety of ways. Okay, you can define, using the typical way of defining a function, which is f of x equals blah 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 blah. Okay, now obviously you have to fill in the blah 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 to make it work. But if you do it this way, you also have to tell me what is your intended domain and what is your intended codomain. Yep.
Would formatting it like the previous questions be good?
Yes, that'll be fine. If you want to make it very easy to read, you can just say the domain is blah blah blah. Is a set of specific elements. The codomain is a set of certain elements, and then you still have to say that the function f is mapping from D to E. Okay, because that is basically saying this function maps from this particular domain to this codomain. And then you can tell me the exact mapping by saying f as a set is the following. Just give me a whole bunch of two tuples, and that's also acceptable. Okay. Are there any questions about number 3 or what is number 3 that we are seeing here? And I think it is the same type of question for the next few. So you do have to clearly state what is the domain and the codomain because sometimes for certain functions, it can be one way or another way, but it depends a lot on what you consider as the codomain. Okay, the codomain is more important in many cases than what you consider as the domain. Yep.
Do we need to write the f of x on top or define it?
If you do it this way, then you don't need the f of x.
All right, thank you.
If you do it with the f of x method, then you have to clearly state what is the domain and what is the codomain. Because a lot of times when you use this format, you're dealing with a set or the domain is an infinite set or a set with infinite elements. So then you cannot define it like this. You have to define it like, okay, x is the domain is a real number, okay? Or the domain is the set of all real numbers. You can limit it too if you want to. You can limit the domain to be all non-negative real numbers. That works for me too. But you do have to clearly state what it is. Okay. So that would be the same thing for a few questions. This is not the only one with that particular format. So if you look at question number 4 or my question number 4 is kind of the same thing, except this one I want a function that is injective but not surjective. So you have to find specific cases to meet these requirements. Number 5, there are 4 questions in this format, okay, because there are 4 ways to make injective and surjective. So this one is injective but not surjective. And then the next one is surjective but not injective. And I think that's one that is neither. Okay, so this one is clearly stating what is the domain and what is the codomain, and is asking you a question of is f a function, and if so, and if not, why is it not a function? Okay, number 8. Okay, so this one, in case you guys don't know what this is the set of all integers. Okay, so in this case, I clearly state, what is the domain and what is the codomain. So given that the domain and the codomain are both the set of all integers, then you have to answer the question accordingly. Now this one is kind of tricky because if I do not give you the definition of what I consider as the domain and the codomain, the answer can be different. Okay. So this is the one where it is important to understand what is considered the domain and what is the codomain. Here's number 9.
Integers can have negative, right? The integers in this case can have
Yes,
negative.
correct. Integers include negative, integers, 0, and all the positive integers. Yes.
Because I just want to make sure, because like sometimes the formal definition of for programming isn't always the same for other things.
The only one that is kind of fuzzy is what we call counting numbers. Some people consider counting numbers including 0, and other people do not consider 0 as a counting number. Natural numbers will go from 0, 1, 2, 3, so basically all the non-negative integers. But when people refer to integers, that typically would include negative and positive and 0 itself. All right, so this is another one where the domain and the codomain are also clearly indicated, so you have to take that into consideration. And this is the last one. So the last one, same thing, okay, integer to integer. So this one is not, well, okay, I'll leave it up to you guys to decide, whether it makes a difference or not. Okay? So that really kind of gives me an inspiration. Maybe in the test, I can give you a function, and I want you to use the domain and the codomain to make it surjective or not surjective, injective or not injective. That would be an interesting test question to ask. So that gives you guys a way to prepare for the test, right? Are there any questions about what I just said? Yep.
Is there such a thing as states? Because when you write f of x equals 2x, there's nothing implicitly right now currently in the domain or codomain, but sometimes when you specify what is in the codomain, is there some sort of state that you would recognize or write it as?
Well, in this case, I have to separate the statement of what is your domain and what is the codomain separate from the actual definition. Yeah, because there's no easy way to include. Well, there are ways to include it, but I chose to do it the other way.
But when you explicitly state the codomain consists of these elements, the domain consists of these elements, is there? I'm not even sure I actually have to ask it, but is there some sort of state, because the
some sort of state.
codomain is currently filled, while when you specify.
You mean something like that?
Yeah.
I'm not quite getting your question. I'm sorry.
I'll probably ask you later. Once I
Okay.
have something more.
Okay. And the way you type up your answers, you can look into how I type this up. Okay, it's easy. You just right-click on the equations. So let's say you want to do something like what I did here with the subset of and use the right arrow. You just have to do a right-click on it and then say show math as, and then use a tech command. Okay, and this shows you this is typed in as F colon and D backslash right arrow E. Okay. Now, when you want to include your own equations like that as a part of your answer, with an HTML editor, what you need to do is do a backslash open paren as a opening for the math equation part. Then you can type out all that stuff. Okay, so you can basically say, okay, E times, okay, this is the little cross times this little cross E. When you're done with the math equation part, you use backslash and close parentheses in order to close the math equation part. Yep.
Is backslash paren the only delimiter you have?
Sorry?
Is backslash paren the only delimiters that it supports right now?
Yes.
Okay.
Yeah. Or if you want it to be standalone on its own line, then you use $$ to start and $$ to end.
Okay, so $$ is supported as well.
Yes.
Okay, thanks.
But this is the only way to do it in place. The $, basically it becomes its own paragraph, and you guys can kind of experiment with that also if you want to. Yep.
Can we preview the result or the text command?
I think so. Let me check, because I am taking the test just like what you would be, how you would be doing it. So let me go to one of those questions with an HTML editor and check it out. So let's say we're dealing with this question here, and let's see what the question is asking so I can give you the wrong answer. Okay, define a function that is not injective and not surjective. Define the domain D, the codomain E, and the function F. Okay, so let's go ahead and do this. So I can say the domain is the following. Now, if you want to use open curly brace, in the math equation side, you have to do a / curly brace, okay? Because curly braces is used up by tech itself to mean enclosure of something. So if you really want the open curly brace symbol, you have to put a / in front of it so that it shows up as an actual open curly brace. So in this case, I can say, A, B, C, D, and then I can say / open. Now, the way I usually do things, and some of you know my style already, is I typically use the open and close at the same time, and then I go back in and fill in whatever is supposed to go in between, so this way I don't forget to close it later on. So now I can say, E is, let's make this fun, empty set. Okay, and in this case, F, okay, so F is a function that maps from D, and right arrow, it will give you the actual arrow, E, / close paren. So let's say that's my answer, okay? And the way you do this is you just click next. Then you have to go back to the previous one, and it will show you what it looks like. I think it does, but I could be wrong. No, it does not. Don't. Okay. So you can't really quite tell what it looks like, by just looking at it.
What if you look at the answer? Will you see the answer in the proper format?
Well, but you cannot check whether you typed it incorrectly or not.
Can you see the proper answer?
I can see the proper answer. I can give you another activity that is not graded, so that you can just play with it and just see the result. So that would be fine too. Or you can just use other symbols to approximate what needs to be displayed. But let me see if I can give you a ungraded activity that you can just kind of play with. Let's see. I have to turn on editing. On another website, yeah, you can go to the MathJax website, and that will give you a preview.
Are you using the math? You're using?
Yeah, this is MathJax. So the other thing you can do is to go to a MathJax website, and let's see. Yeah, there we go. So if you just type your MathJax preview and look it up in Google, it will give you, this is the first link in Google. And with this one, you can do exactly what I did earlier. So you basically just type in, the stuff. You know what? I can do. Oh, I got out of the test already. But this is the beauty of a test. I continue the test, and I'll just go ahead and copy and paste this portion here. I think you don't need to copy and paste the / open and close paren. You just need to copy and paste whatever is in between. So that's that, and then you paste it here. Oh, I guess not. You do need the open and close paren here. There you go. So this is a quick and easy resource for you guys to review, whether what you type is shown up as what you want it to show up as. Any questions about this part? Questions? There's an easier way to do it too, but I'm not sure whether the easier way is going to work well or not. So we'll give it a try. Okay. The HTML editor has a built-in equation editor. Now you mention it. Okay, the built-in equation editor, I think is, okay, where is it? I thought it had one. I think it's this one, equation editor, that's it. So if you click on equation editor, it will give you like a kind of somewhat what you see is what you get type of thing, but it's not really what you think it is. Okay, so in this case, it does give me the equation here. But if you want to say that D is a proper subset of something, you click a button, but it doesn't give you the subset symbol. It gives you what you need to type to get the subset symbol. So this way, you can kind of learn how to use LaTeX using a kind of more user-friendly interface. But to preview this, you still have to put it into the other preview window to show the actual rendered content of this stuff. Are we doing okay so far with this? Okay. Yep.
Is this built into Moodle, or did you have to like load something in there to make it?
No, this is in Moodle.
Oh, okay.
It depends on which editor you are using. So this is okay. This is the other thing I can show you is how to get to this part. If you go to your user profile, if you go to My Profile and edit it, let's see, where's my edit profile? In edit profile, it allows you to change your default editor. And let me see where it is located. There we go. So when you look up text editor, it gives you several options. Mine is defaulted to the ATTO, ATTO HTML editor. Yours is probably defaulted to Tiny MCE HTML editor. So if you want to use the equation editor, you might have to switch to ATTO HTML editor in order to use that feature. Any questions about this part? Does anyone know whether your editor is defaulted to Tiny MCE? Yep.
It's actually the default.
Which one?
Default.
Oh, you're using the default editor?
Yeah, that's the
Yeah, the default editor, if I remember, is Tiny MCE. So you probably have to change it to ATTO in order to use that particular editor. All right. Any other questions? Now, if you really don't want to mess around with all this stuff here, as long as I can understand your answer, it will still be okay. So you can just kind of type as much as you can using just regular typing. And when you need to put in like a subset of, symbol, something like this, instead of this, you just use your English word and say subset of, and that will still be okay. Now, but in this case, when you say subset of, I will understand it as this particular symbol. If you want to express this one, you have to say proper subset of. Okay, so you do have to be kind of careful when you are dealing with stuff like this, because I go for the most specific definition of these symbols. All right. Any questions about the typing in the yep?
Where do you find the dynamic
Say again?
Where do you find the dynamic reviewer?
The dynamic reviewer previewer is you just use up Google. You use Google and search for MathJax and preview. Yep. I can just put a link here into Moodle. So let's go back a few levels back to here. Okay, I'm just going to put a link into the class website. And I'll put it on the top, so it's not going to be specific to function, because you might find it useful in other places too. So I just put a link here. So URL. This is a MathJax reviewer. Link. There we go. So now that link is on Moodle, and you can just utilize that resource. Yep. All right. Any other questions regarding the homework assignment? No other questions? Good, because now you have a new homework assignment. Another one. Well, because I think it's useful to have more, homework assignments, so that you can kind of practice all that stuff. And I need to go find out where it is. Course intro. Okay, we can jump to functions and relations. So the new homework is right here, more on functions. That one is due next Thursday. So you have one due on next Tuesday, and this one is due on next Thursday. It's basically the same stuff, related to functions. Okay, so there's no new stuff. And this one is all multiple choice also. Okay, so there are no open-ended questions, all multiple choice. Any questions at this point? Yep, go ahead.
When's the next exam again?
The exam is going to be in week 6 or so. Which week are we in?
3.
3. So we have about 2 more weeks to go. I'll give you a practice exam before the actual exam, and the practice exam is going to be 1 week before the actual exam.
Is that worth anything?
The practice one?
Yeah.
No, the practice exam is not worth anything, but it does give you an idea of what type of question I'll be asking, and just give you a general sense of how to prepare for the exam. But I cannot guarantee any amount of similarities between the practice exam and the actual exam. I'll try to make it useful as a practice exam, but I cannot make any actual guarantees. Yep. All right. So any other questions regarding functions or the homework assignments? Okay. No questions. Yep. Go ahead.
Is it safe to assume that all the quizzes you give from now on are going to be similarly structured to basically we can start it anytime we want, and there's not going to be
Yeah, I would say so.
Okay.
Yep. Mm-hmm. Okay, so if there are no questions about functions, we are moving on to the last topic of this particular, or the last link of this topic, which is binary relations. All right. So first of all, we have to go, talk a little bit about the terminology of what is a binary relation. Binary means 2. Okay, so basically this is a relation that relates 2 things. Okay, so it's basically stating whether 2 things are related or not. Now, what type of relation are we talking about? It doesn't really say, okay? So a relation R over a set X is basically a subset of the Cartesian product X times X, okay? In other words, R is a subset of X times X. If an element X, lowercase x, if lowercase x is an element of uppercase X relates to another element Y, which is from the same set through R, then we use the notation X, R, Y to indicate that X and Y are related using the relation R. Which also means, you will find this particular element in R. So in some way, relations are kind of like a function because it is telling you this thing from this side is related to that thing on the other side. But it doesn't have the limitations that you have in functions. In other words, there's no such thing as a requirement that every element from the left-hand side has to map to one and only one thing on the right-hand side, which is a requirement for function. So relation is far more flexible, and it's just basically saying, okay, tell me how things are related. Maybe nothing is related at all within those sets. So you have a relation that's an empty set. That is actually okay if it is a relation. It is not okay as a function. So are there any questions about what is a relation? No questions about a relation? So a lot of relation is actually used in computer science. Whether you are aware of it or not is a different question. All comparisons can be seen as relations. In other words, when you look at integers that we use in in programming, you can now say, okay, let's consider this as a relation. It's less than, right? And we'll consider the set to be integers and integers. So now we want to express, okay, how are the values that we deal with relate to each other? So you can say, oh, that's easy. 3 is less than 5. That's a relation. 3 and 5 are related through the less than relation. That's all we are going to say. Is that okay? So you can probably give me like a whole bunch of examples, right? 1 is less than 3, and so on. These are all examples of relation. So the other way to express this is to say less than as a relation is a subset of I times I, which is the Cartesian product of integers and integers. Okay? But the way we define this, you can also enumerate all the ingredients or all the elements in the set. So you can basically say, okay, 0 is less than 1, 1 is less than 2, 0 is less than 3, and so on. And you can definitely tell that this is going to be a really, really huge, or it has an infinite number of elements. Are we doing okay so far as, in terms of what is a relation? A relation is a set of two tuples, but the restriction is the first element of the tuple and the second element of the tuple, they have to come from the same set. Okay, you cannot have one set for the left-hand side and another set for the right-hand side. They both have to come from the same set. Yep.
Is it a subset or proper subset of the Cartesian?
I think it is only a subset, not a proper subset of, so I have to correct my notes regarding that one. Okay. Any questions? So we can express, another relation here. This is an example. If we are considering equality, okay, what equals to what, then R can be expressed like this. We can basically say R is a set that contains XX as two tuple, where X only has to be an element of the set of all integers. So that will basically define the set of all relations using equality. Are we still doing okay so far with that particular example? So the next question is, before we move on any further, what other relations do we have to deal with in programming? Because I don't want this class to be completely a math class. I still want it to be related to what you have to deal with, in programming, in developing your code. So what other relations do you have to deal with in programming, other than the ordering of numbers? What about object-oriented programming? Classes, okay? So how do you relate one class to another class? Inheritance, or what is the name, what is the term when you have a class and then you have a superclass on the other side? There are two ways to call that. You can say this is a class derived from the other class. You can also say this class is a subclass of the other class. Okay? So is a subclass of is a relation. Are we doing okay so far with these concepts? So now we can move on and talk about special properties of certain types of relations. A relation R over a set X is called reflexive if for all x, lowercase x, and uppercase X, this exists. So if a particular relation has this property, then it is called reflexive. Now, in addition to being reflexive, it can be something else too, okay? But this is the minimum requirement to be reflexive. Are there any questions about what is considered reflexive? So in this case, I also give you two examples. I gave you two examples. Equality is reflexive. Greater than or equal to is reflexive. Less than or equal to is also reflexive. Okay? Okay, let's take a look at those three examples. And well, there are only really two because greater than or equal to is kind of the same thing as less than or equal to, so I only explain one of them. Okay, so I'm going to use a mouse pad here to explain that. Okay, let's look at equality. And in this particular case, I'm going to confine myself to a much smaller set just so that I can enumerate all the possible cases. So I'm going to consider uppercase X to be my set of elements to consider. And we'll just deal with 1, 2, 3 here. Okay, so we are not even considering all integers. I'm confining myself to only 3 elements. And we want R to be the relation that is representing equality. So we know that R is a subset of x times x, the Cartesian product of x and x. So, but we want to know exactly what would be in R. Okay. Now, since we're dealing with equality, so let me just make it clear here and say R is equal to, that's the relation. So if you look at the actual definition of R, it really only has 3 elements. It has 1, 1 as an element, 2, 2 as an element, and 3, 3 as an element, and that's it. Because this time I just want to express equal to. When you look at the relation and you look at the set X, can I claim that for all elements in X, X Rx is in the relation? Yep, we can definitely claim that. Is that okay? I mean, are there any questions about how I define the equal to relation? Or if you prefer to have the grammar fixed, you can say is equal to. So that way, when you substitute 1 R1, that basically says 1 is equal to 1, or 1 equals 1. Okay. Any questions about this one? No questions about this one? We'll move on to the next one. So the next one, it defines R to be is greater than or equal to. This one is a little bit trickier because it has things other than what we need. So the whole illustration is we can contain other things. It's just that we need to have at least certain things in the relation. Okay, so the same thing, this time R is greater than or equal to, and I'm still using the same set. Okay, X, uppercase X is still just 1, 2, and 3 as elements. But this time, what is, how do I define R? R equals to what? Well, this time we have a lot more, right? Because 3 is greater than or equal to 1, 2 is greater than or equal to 1, 1 is greater than or equal to 1. Then we can also say 3 is greater than or equal to 2, 2 is greater than or equal to 2, and the last one is 3 is greater than or equal to 3. Is that making any sense? If the relation is greater than or equal to, then in addition to the equal to stuff, we also have to add the greater than stuff. So now the question is this particular R, which is greater than or equal to, reflexive? And so the question now is, for all elements in X, is XRX in the relation? Well, we can still find 1R1, we can still find 2R2, and we can still find 3R3. So that means is greater than or equal to is also reflexive. Are we doing okay so far with the definition of what is considered reflexive? Okay. What about is greater than without the equal to? So let's take a look at that one. So if we consider R is just is greater than, and we consider the same 3 elements in X, 1, 2, 3, then this time when we define the actual relation, then we have 3 is greater than 1, we have 3 is greater than 2, we have 2 is greater than 1, and that's it. So when you look at this particular relation, it is no longer reflexive, because for each element in X, which is 1, 2, or 3, I cannot even find a single one that is related to itself in the relation, let alone all of the elements. So that means in this case, R is greater than is not reflexive. One thing you can also remember is reflexive kind of implies a mirror. In other words, if an element cannot see itself through the relation, then it is not reflexive because it cannot see itself. The relation itself cannot serve as a mirror. Is that analogy kind of working or not? Sort of? Okay. So getting back to the notes here, the next one is symmetric. Symmetric means if I find two elements in the set X, one is called X and one is called Y, if I can find one, okay, X, R, Y, then I should be able to find the other one, which is Y, R, X. Okay? Are there any questions about the definition itself? Give me two elements. Now, those two elements may or may not be the same. Okay? Give me any two elements of the set X. If I find, they are related using one way, then they should be related in the other way as well. That's basically what symmetric means. Any questions about this? Yep.
So you said, like, let's say it was 1 and 1, that would still be considered symmetric? They're just the same. Like if X and Y
Yes.
is the same.
Well, symmetric implies reflexive. Because it has to be, if something is reflexive, it has, excuse me, the other way. If something is symmetric, it has to be reflexive as well. But not the other way around. Well, let's take a look at some examples here. Equality is symmetric in addition to being reflexive, because if you say 1 equals 1, well, it implies 1 equals 1, so it works out. In other words, when we look at X and Y, they do not have to be different. We are not talking about, there's no restriction that X and Y have to be unique. They can be the same thing. Are we still doing okay so far with this? Okay. Yep.
Do all relations in that have to be symmetric, or just one for each of the?
Well, relations can be neither, can be none of the above. So these are basically characteristics that we can use to describe a relation.
Well, let's say that one is symmetric, and so like maybe there's a 1,6 and a 6,1.
Mm-hmm.
Could there also be a 1,5 in that and still be symmetric because it already?
Oh,
has
you're
symmetry
right.
in that?
Well, if you can find 1,5, if you can find 1 R5, then 5 R1 has to be there too.
Okay, so everything has to be symmetric with something else.
Correct.
Okay.
And because of that, I correct myself. Symmetric does not imply reflexive, because it basically says if one is there, the other one has to be there. But if one is not there, the other one does not have to be there. So I correct myself. So make a note. Cross out what I just said about symmetric implies reflexive, because it does not. Okay. Any other questions about symmetric? Okay, let's go through a few examples, and I'll go through some kind of extreme examples here. Okay. So this time, R really does not have any particular name. I'm just going to define it the way it is going to be defined. So we are still considering X, as 1, 2, and 3, and I will define R as the follows. Okay, R is an empty set. Is it reflexive? It's cannot be reflexive, right? Because if X has 1, 2, and 3, in order for R to be reflexive, 1, 1, 2, 2, 3, 3, they must be in the relation in order to become reflexive. The question is, now, is it symmetric? The answer is, it is symmetric, because there's no relation whatsoever. So the statement of, if X, R, Y is in the set, Y, R, X also has to be in the set, is still true, because it is empty. There's nothing there. Okay. Okay, so this is one example. We'll go for another example. Just so that we know, how, it is defined. So same thing, X is 1, 2, 3, and this time I define R to be 1, 2, 2, 1, 1, 3, 3, 1, and 2, 3. Okay. So now the question is this relation symmetric? It is not symmetric because 2, 3 is there, but 3, 2 is not. Okay, so that's why it is not symmetric. Very good. Seems like we are getting a pretty good handle on this. So let me give you another example. Okay, so we have 1, 2, 1, 3, and 3, 1. In other words, 2 is not even mentioned whatsoever in R. Now the question is this symmetric? The answer is yes, okay? Because in order for something to be symmetric, it simply means if you can find 1, 3, then 3, 1 has to be there. Now you can say the same thing, but what about 2, 3? It is missing here, completely. Well, since you cannot find 2, 3, you don't have to find 3, 2. So let me ask you another question then. What can you say about the cardinality of a relation that is symmetric? And only symmetric. It has to be even number, right? Sort of. Because if you have the same elements, then it does not have to be symmetric. 1, 1, 2, 2, 3, 3. Yep. So I can. All right, very good. Okay, this is the last one. Okay. 1, 2, 3, and the relation is really just 1, 1. To illustrate, the number of elements does not have to be, even. Is that symmetric? It is symmetric. Is it reflexive? It's not reflexive. Now, hold on a second here. How can this not be reflexive? Because 1, 1 is clearly reflecting itself. But what about 2, 2 and 3, 3? Those are all missing. In order for a relation to be reflexive, every single element has to reflect back to itself. In this case, only 1 out of 3 elements is reflecting back to itself, so it does not meet the requirement of being reflexive. On the other hand, it is symmetric, because if I can find 1, 1, 1, 1 is there. So it is still symmetric, but not reflexive anymore. Is that okay?
Yes.
Question? No? Okay.
Question?
Yep.
The example where you have 1, 2, 2, 1, 1, 3, 3, 1, and 2, 3, that's neither reflexive nor symmetric?
That is correct. It is not reflexive because I cannot find 1, 1, 2, 2, 3, 3. And it is not symmetric because I can find 2, 3, but I cannot find 3, 2 in it. Yep. So your interpretation is correct. So are there any other questions? Does anyone want to come up with an example and say, okay, but what about this one? Is it reflexive, or is it symmetric? Or is it both, or is it neither? Does anyone have any questions? I mean, you guys can definitely pitch in and say, what about this case? No? Okay, well, if you can. Sorry?
An empty set.
An empty set is already. Oh, you mean an empty set for X itself?
Yeah.
Well, that's a good question. Okay, so let's take a look. If X is an empty set, then the only relation you can get is what? Has to be an empty set. So now the question is it symmetric? Well, every element, which is none, is, reflexive, and it's also symmetric, because I cannot find anything or whatever, so I don't have to find the other one. Yep.
So in the example that's 1, 3, 3, 1, you said it's not reflexive because there's no 2 being represented, basically?
This one is not reflexive because 1, 1 is not there, 2, 2 is not there, and 3, 3 is not there.
So in the very first example, though, you said it was reflexive, but
This one?
no, the one at the very, very top.
One very top.
Down a little bit.
This one is reflexive.
No, not that one.
This
the
one?
Empty set. The one with the empty set.
The one isn't. This
you
one?
said that was reflexive, but neither 1, 2.
No, this one is symmetric, but not reflexive.
Oh, okay.
But if I said
maybe,
it is,
maybe
I might
that's what
have
was
misspoke.
thinking. You might have said it correctly.
Okay, all right. I can roll back the tape and check, but I can just restate
You don't need
it.
to prove me wrong. I think you
No,
said it
I can
right.
be wrong too. I cannot remember what I said. But this one, just to restate
So it's
it,
symmetric.
this one is symmetric, but not reflexive.
Okay.
Okay. Any other examples that you guys want to go over? Nothing.
The sets are exactly the same.
Hmm?
They're exactly the same.
Say again.
They're exactly the same.
What is exactly the same?
Both sets.
Huh?
Both sets. But if they're both 1, 2, 3, 1, 2, 3.
1, 2, 3, 1, 2, 3.
Yeah. You asked for a question, I just gave it.
But that is not a relation.
So you answered my question.
Okay. All right, so getting back to the notes here, we have transitive next. Transitive means, okay, all it really means is if you can find x, r, y, and you can find y, r, z, then x, r, z has to be there. And there are a lot of transitive relation that we deal with on a daily basis. Okay, so let's think in terms that we actually already know. What about equality? Is equality transitive? If I can claim that A equals B, and I claim B equals C, does that mean A equals C?
Yes.
Yep, okay, so equality is transitive. What about greater than or equal to? It is transitive. What about just greater than? It is transitive. Less than, transitive. Less than or equal to, transitive. Is a subclass of transitive, right? Because if A is a subset of B and B is a subset of C, A is, excuse me, a subclass, then A is also a subclass of C in the class hierarchy. Is that working out so far? Okay. So transitive is actually found a lot in programming. Symmetric, not as much. Okay. Any questions about transitive? Yep.
Not about transitive, but just the way you represent the x, r, z. Can you explain what that means again?
Say again?
Can you explain what that means, the x, r, z? Like just the way that you.
Okay, so what this means is, this basically means x, y. If x, y is in the relation and y, z is in the relation, then x, z has to be in the relation too. That's basically all it's saying. So instead of using the subset element of thing, it's using r to join the x and the y or the y and the z, just as a shorthand basically.
Gotcha.
Mm-hmm. In other words, if I want to, I cannot do this. This is such a great tool because now I can use this for this purpose too. Okay, because this is kind of like my new scratch board, so I can type in equations. Okay, so what I can do is I can basically just say x, r, y, okay, is basically saying the same thing as x, y, x, comma, y, in R. So is that okay?
Yeah, that's
Does
better.
that make sense?
Yeah, because now, before I looked at your definition, I didn't understand your definition, so
Right.
it doesn't.
Yeah. So the reason why we use x, r, y instead of x, y is in R is just because this is a lot more concise. But it means exactly the same thing. In other words, if x relates to y through R, it's basically saying the same thing as xy as a two tuple is in the set R. Yep.
Do we see an example of a relation that is not transitive?
Something that is not transitive?
Yeah.
Unequal to.
Not equal to is not transitive. That is correct. Is that okay?
Is negation isn't transitive either. Negation.
Negation?
If A is not.
But negation is not a relation. You cannot have a negation relation because negation applies only to one operator. Is that working out?
Yeah.
Okay, any other questions?
So, other than not equal to, what are some other non-transitive?
If you have a system that is not completely ordered, then the greater than, even the less than may not be transitive. I have to think of an example. That's a really tough one. That's a really kind of interesting question because most relations are transitive, and I can give you even a longer list of transitive relations. Like it's a file in a folder. Okay, so you pick out a file or a folder and you ask the question: is it in another folder? So if A is in a folder B and B is in a folder C, A is also quote unquote contained in folder C because it is under that particular directory tree. A boss of, okay, is transitive. A is a boss of B and C is a boss of, to take it back, A is a boss of B and C is a boss of A, then it is transitive. Okay, who's in charge of what? But to make it non-transitive, transitive is kind of difficult. Most relations are transitive. Not equal to is one example. What about subset of? Is it transitive or not? It is transitive. All right. Any other questions? No questions? All right. Well, if there are no questions, we are really kind of done with relations. That's it. That's the end of a relation, except for the last one, which is equivalence. So equivalence means that R has to be oh, okay, I used the wrong word here. This is supposed to be equivalent. Is equivalent. So R is equivalent if it is reflexive, symmetric, and transitive all at the same time. So you need all three properties in order to call something equivalent. I'm going to fix my note right away. So because this is supposed to be equivalent to. Let me just fix that. All right, so that is now fixed. All right, are there any other questions about relations? Questions about all this stuff? Do you see any relationship between functions and relations? There's definitely a relationship between those two, okay? And I think in this class, let me just go back to the top level of this class because I think we have to talk about graphs at some point. And pretty sure about that. Yeah, so eventually we have to talk about directed and undirected graphs. And basically what a graph is you have a bunch of elements and you're basically just saying, okay, which element is directly linked to which other element? And it can be directional, which means that you can only go from A to B, but not from B to A unless BA is also in the set. So now the quick question is, why do we want to study graphs, okay, or graph theory? Does anyone have any idea how graph theory fits into computer science? Or which branch of computer science has to do with graphs?
Linked list.
Say again?
Linked list.
Linked list. Well, linked list is a good way to implement a graph, but in terms of theoretical use of graph theory, linked list is just an implementation. It does not make use of graph theory. So any ideas? And by the way, you cannot really even take a class in graph theory until you get to graduate school. Okay, so it's a pretty high level concept. It's really abstract in terms of mathematics, but it does relate to computer science. And in fact, it relates to a pretty useful branch by today's standard of computer science. And it has to do with Turing a little bit too. No idea? Okay. But I do want to show it to you because I want to make sure that you guys understand all of this stuff here is not really just abstract and somebody has to sell a textbook and that's why we have to study all this stuff.
AI.
Well, not AI. It's actually far more practical than that. It has to do with cryptography. Yep, that's it. So if you look up cryptography and graph theory, cryptography actually make use of a lot of graph theory stuff. But that's actually higher math. I took one class in graph theory when I was in graduate school. And the class size was about 10, I think. So there were about 10 graduate students in that one single class. And I got maybe about 50% of the content of the class at the time, at least. So it's a pretty high level math class, but at the same time, that's actually directly related to cryptography. And cryptography eventually connects to what? Security, okay? Computer security. Because if a particular cryptography, is weak and we use it, then what happens? It can be cracked, right?
You mean like SSL?
Have I shown you guys the live picture of, how, attacks are launched on an international scale? It's kind of like a live picture, No? I haven't shown this, guys? Okay. So I think it has to do with NOR's security. Real-time map, that's it. There we go. This is something that you can show other people too. It shows you the origin of an attack and the destination of an attack. It shows you all kinds of statistics too. So if you just kind of leave, let it run for a while, you will find a pattern. Oh, this is nothing. This is nothing yet. Okay, sometimes the whole screen will be filled up by comments.
How do they determine what's an attack?
You can look at the details too.
Oh.
So when you look at the scrolling stuff, it actually tells you, what is the destination and why they think it is, an attack.
They're repeatedly pinging. They're repeatedly pinging like telnet ports and other.
Yep,
common
SSH.
ports.
Microsoft SQL is attacked a lot too. That's also a very common deal.
NTP is attacked a lot too. It looks like.
Yep.
What does that tell you?
Yeah, you guys haven't seen anything yet because at this time it is not daytime yet in some of the other countries where most of the attacks are launched from. So wait until it is about like 10 a.m. in those countries, then you start to see some real fireworks going on. This is nothing. This is like really quiet.
These are all botnets. This is usually just.
Some are bots, some are not. So
Well, if a non-bot is doing that many attacks, then that's a really fast person.
yeah, but it doesn't explain why time makes a difference. If it's all done by bots, then we should be seeing the same pattern 24 hours the same way. But if you look at the actual pattern, when it's daytime in the countries that tend to launch a lot of attacks, during the daytime you actually see a lot more activities, which makes this look like, oh, this is a dull day.
How are they able
Yep.
to do that in real time? How are they able to do this in real time?
That's a good question. I really do not know. I just found out this resource from one of the conferences that I attend to, like in last month, and they showed us these attacks, basically go like, wow, I didn't know the frequency is that high. All right. So at this time, I'm gonna leave it to the Computer Science Club or the Dev Club to promote their cause.
Renaming us now?
Are you guys still Arc Dev or Computer Science? Technically, okay. So technically the Arc Dev Club.
All right, I'm Nathan, and this is Danny, and we're representing the Computer Science Club. And this semester, we are focusing on game development, pretty much entirely out of interest. Everyone in the club was interested in that, so we're switching to that. And we have two main projects going, and I am leading one project which is focused on learning UDK, basically, which is Unreal Engine 3's free developer kit. And with my project, we're basically just trying to manipulate a 3D environment to create a unique product. So a simple design choice I'm aiming for is just Pong in a 3D environment. And it's pretty free form on that project. We're just trying to make a game. So far, I've made some cubes that fall and then don't fall through the ground. So I feel pretty accomplished on that. And Danny is leading the other main project,
which is a mod for Skyrim. It's going to be a whole full-on quest mod with its own race, new weapons and armor, and a whole quest line for this guild. So there'll be actually several quest
for both of these projects, we're using like scripting languages, which are based on languages we're learning here in school, but not the same. So it's a lot of learning and a lot of experimenting and Googling. To be involved, it's recommended that you have a laptop that runs Windows, and like for UDK, the minimum requirements is 2 gigs of RAM and some kind of graphics card. So not too steep an entry point, but still something. There are workarounds that you could probably figure out. We aren't focusing on that too much right now, a little bit, but not too much. But if you want to come around, we're Tuesdays and Thursdays from 12 to 3 over in room 152D in liberal arts, which is a little classroom in the computer lab. And you can come for part of it. You don't have to come from at the beginning. You don't have to stay till the end. You don't have to come twice a week. You can come once a week. You can come once a semester. It's totally available for drop-in just to see what's going on and talk to people about programming. Any questions?
What scripting language are you using?
For UDK, I don't know what they call it. It's UDK's proprietary language for
name it Unreal Script.
Unreal Script. So, and for the Skyrim project, it's Pyrus, is what they call it. Yeah.
So why UDK and not Unreal 4?
We're actually working on getting Unreal 4 licenses. TAC ordered some for us. So if that comes through, we'll switch to Unreal 4 because it's more powerful.
And provide free licenses for students.
Right.
Well, the reason why we're doing UDK 3.0 is that it's free as long as you don't make profit. So you can just download it. It doesn't matter that you're a student or not. If we do UDK 4, it's only because we're students.
Right. And there's theoretically, if you want to take something you start in the club and go off and try to make money off of it, it's a little bit easier to start from UDK, the general. Yeah?
You're actually not allowed to do that unless you purchase a full license.
Well, you're going to have to deal with licensing in some way, but it's
Yeah.
easier than using the student license. Yeah. So that's our club.
So I just looked it up. Unreal Script is influenced by C++ and Java, which means they're not the same.
You can only inherit once.
Yeah.
But they use curly braces, right?
They do use curly braces.
I can learn it then.
And sometimes
Sometimes. Right.
And
So.
you are the faculty advisor.
Mm-hmm. Yep. I just have to make sure they don't do anything that is,
Quote unquote illegal.
yeah. Not when they're there. Okay, so what we're going to do now is to move on. So after all the functions and relations, we are now moving on to, well, back to some more cardinality, because there's one topic that we did not go through because we did not have the necessary tools to talk about it before. And that has to do with, what about, a set that has an infinite number of elements? Okay, and there are many, sets of that nature that have infinite number of elements. So how do we describe, how big these things are? Can we still say that one set is larger than the other one, even though both have an infinite number of elements? Those are the questions that we want to answer. And this gives you a, well, I would say a partial answer, because it's really just the starting point of, how do you count number of elements in a set. So what happens here is we can have sets that have an infinite number of elements, but we will still call those, countable, okay? And this is basically, what it is. So it makes sense to get the cardinality of a set of finite numbers of elements, okay? So we have done that already. If you know ahead of time that you have a set of just 3 elements, okay, then we can say the cardinality of this set is exactly 3, okay? That's easy. But what about the set of all integers or the set of all natural numbers and stuff like that? The only thing we know, like in this case, let us consider the set of natural numbers. Natural numbers are 0, 1, 2, 3, 4, and so on. Okay, and obviously this particular set has an infinite number of elements. This is supposed to be uppercase n. It's supposed to look like this, but it's not a finite number. Okay, the cardinality is not a finite number. But how do we state it? Okay. So what we do is we say the cardinality of natural number as a set is this particular symbol. Okay. When you right-click on it, it will show you how to enter this really kind of awkward symbol. And there's a particular pronunciation which I have quickly forgotten after I looked it up. It's ALEPH, and let's look it up. ALEPH.
Aleph?
Hmm?
Aleph?
Yeah, I think it's Aleph. 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 It's Aleph. Aleph. So Aleph is the symbol. Aleph 0 with a subscript 0 is how we describe the cardinality of natural numbers as a set. Okay? And it's just a symbol. Okay? As far as we are concerned, it really is just a symbol. So any set that can map to the set of natural numbers using a injective function is called countable. Okay, so these are all definitions. Okay, so don't there are no proofs whatsoever at this point. So let me just kind of focus on this one here. So any set that can be mapped to natural numbers using an injective function is already classified as countable. And what is? Remind me again, what is injective? No two elements from set S can map to the same natural number. Okay? So as long as we can find a way to map it like this, it is called countable. Even though set S can have an infinite number of elements too. Now on the other hand, if you can establish something even better, like if function f is also surjective, which means f is now bijective, then you can call set S countably infinite. Okay, that's just a name. Okay, it applies not to f but to the original set S. So this needs to be corrected as well. So we'll show you a few examples. So here is an example. Let's look at all the integers. So if you look at a set of integers, the question is, how does it relate to the set of natural numbers? Is there a way to have a bijective function to map all integers to the set of natural numbers? That is the question. Now, it doesn't have to be a particular way. There may be like 20 gazillion different ways to do it. All I need is just one way to do this mapping. Then I can claim that integer I is infinite, countably infinite. So the question is, how do we do that? Okay, let's use a picture, because the picture makes more sense. The answer is there already, but I don't want to just talk about the answer, because I want to talk about how do we get to the answer. Okay, let's start with integers. Integers has 0, plus 1, plus 2, plus 3, and so on. But it also goes on the negative side, which is -1, -2, -3, -4, and so on. In other words, unlike natural number, which is from 0, 1, 2, 3, 4, and so on, this one is growing on both sides, whereas the other one is only growing on one side. How do we do a bijective map from integers, which can grow on both sides, onto natural numbers, which only grow on one particular side? That is the question. And the answer is, well, we can do a function that can map values depending on whether it's positive or negative differently. Are we still doing okay so far? So for non-negative numbers, I could go like this. Okay, 0 goes to 0, 1 goes to 2, 2 goes to 4, 3 goes to 6, and so on. So I'm leaving out these odd numbers for a reason, because I want. Yep, go ahead.
So in other words, in order to map the set of all integers to the set of all natural numbers, you map all positive integers to
all even natural numbers and all negative integers to all odd natural numbers.
Right, correct. So now I can map -1 to 1, -2 to 3, -3 to 5, and so on.
So the function of that is what, like 2x for all evens and 2x minus 1 for all odds? Or for all negatives?
Yeah, if x is,
Oh.
okay, so it's already written there, so we can define f of x to be 2x for non-negative integers x. And then for negative values of x, then we define it to be 2x minus 1.
Okay.
Negative 2x minus 1 because x is negative.
Okay.
Okay, so if x is negative, like -1, then negative 2x is 2, and then 2 minus 1 is 1. Okay? So this function turns out to be both injective and surjective. So that's why we can now claim the cardinality of all integers is the same as the cardinality of natural numbers, because now we can have a one-to-one mapping. Are we doing okay so far with this one? And you can see the trick is pretty easy with this one. We just basically fold the integers onto itself, and then just leave every other space. So we have every other space for positive numbers, and then the leftover are for the negative values. Yep.
The cardinality of that would be the same, though, correct? Because both are going to infinity. It doesn't really matter that the other one's going to negative infinity as long as they're both going to infinity in general.
So what we do is we say the cardinality of natural numbers is considered the same as the cardinality of all integers, and we define that to be
Aleph not?
aleph, which is I have to look up how to write that.
That's about right.
It's curved on the other side. So it's curved like this, and like that. I think that's closer.
Good enough.
Good enough, yes. And aleph is actually one of the Egyptian. It starts off as an Egyptian.
Can you write it in Phoenician?
Hmm?
The Phoenician way is just that.
But in Egyptian, it's basically a cow head with 2 horns. All right. So, are there any questions about integers? Why we can claim integers are countably infinite? Because there's a bijective function to go from all integers to natural numbers. Yep.
What about the cardinality of all real numbers?
Real numbers are not. Okay, real numbers do not have a cardinality of aleph 0, because there's no way to make that mapping. Yep.
So in that example, there's nothing that maps to negative numbers? Is that a problem, or is that?
Nothing to map to negative numbers, because natural numbers do not have negative numbers.
Okay, so the mapping to is the natural, but you can map from non-natural?
Right, because the set in question here is the set of all integers. Okay, let me restate this part here.
The domain is natural numbers and the codomain is the integers.
This is by definition. So we look at the cardinality of all natural numbers, and we call it aleph 0. And that is by definition. There's no particular reason. We just say, okay, we will define this as a symbol to mean the cardinality of natural numbers. Okay, so this part is quote unquote not questionable because it is just a definition. But this part is questionable because in order to establish the cardinality of one set is the same as the cardinality of the other set, we need to have a bijective function to say, yes, for every element from here, we can map to an element over there and back, the other way around as well. Then we can establish the two sets to have the same exact cardinality. Even though both can have an infinite number of elements, we can still say they have the same cardinality. And in this case, the symbol to represent that cardinality is aleph 0. Is it okay so far? Yep.
The thing is, though, the functions, you'd have to define that the function only works, like, if you were to write it out in notation, it would be such that x is mod 2 is equal to 0, correct? like in order to map even numbers correctly, and not like because you have two different functions to define how the mapping works. One set of x or one.
No,
set
but
of,
it's the same function because it's just a closed form of a function. Okay, that's a good question. Okay, so let's go ahead and kind of roll back a little bit about what is a function. Okay, what is a function in this class? Because I know what you know about the function in the other classes, especially in calculus, because they are more concerned about the closed form of a equation, right? So let's go ahead and talk about something as simple as f of x is just x plus 1. Okay? To a mathematician or typical math professor, this is how a function is defined. Okay? This is the parameter or argument, and this is how it is expanded, and that's how you define a function. But in this class, the way we define function, one way is to look at it this way. But the other way is to look at it as a function is a set of tuples. That's how we look at it. So as far as we are concerned, okay, so in order to make this definition fit into our scheme, we also have to define what is the domain and what is the codomain. Because if the domain is integers and the codomain is real numbers, it changes the properties of the function. So now, let's just say that we are dealing with integers. So we are dealing with integers as a domain and integers as a codomain. So now, how do we express this function? In this class, we can express the function as 0 maps to 1, 1 maps to 2, -5 maps to -4, and so on. So using this particular view, the way I define that particular function f, the one that is highlighted, is perfectly okay. Because I'm separating it into two cases. If the element from the domain is positive, use this way to do the general mapping. If it is negative, use this way to do the general mapping. As long as those two rules do not conflict with each other, I still have the definition of a proper function.
How would you show that using predicate logic?
Say again?
How would you show that using? I forgot now. Yeah. How would you show that using first order logic?
Using first order logic. Well, there are several ways to do it. You mean this one here? The way I define my function f here?
That entire thing.
The entire thing.
Like, how would you show that using those two, like using predicate logic, how would you show that those two functions?
You don't need to use predicate logic for this one. Okay, so one way to define this is like that. Okay, so I'm gonna erase this. This becomes my favorite whiteboard now. Okay, so you can basically define that particular f to be like this. So f is a set, and we'll use union. Oh, I guess no. It's not called union. If you want to do a union, it's called a cup. If you want to do an intersection, it's called a cap. Yep. All right, so you can define it like this. You can say it has elements of x, y, such that x is an integer, right? So we basically use math BB uppercase I to represent integers. And then wedge, which is and, x is greater than or equal to 0. So basically I separate it into two sets. One set will deal with the non-negative values, and the other set will deal with the negative values. And we have to put the overall parentheses here, and then we say this implies is right arrow, but with the uppercase R. Otherwise, it's one single bar with the arrow itself. So this implies y equals to, what was it? Just 2x in this case. So this is how I would define the positive side, and then the negative side would be something like this, but with x being less than 0.
And y would equal to -2x.
Right, but the function is a union of those two. So now I have all the tuples that I need in order to define the actual mapping. So this is the the other way to define it, but without using English words and say, oh, for x that is non-negative, use this. For x that are negative, use the other one.
I was just curious.
But hopefully that answers your question. Yep.
Can you repeat his question? I didn't.
Chris' original question was, how do we use predicate logic or quantifiers to define, that particular function, which has basically two portions, because one portion is applicable to elements that from the domain that are non-negative, and the other one applies to elements from the domain that are negative. So how do we, use predicate logic for that purpose? So that was his original question.
It's also
All right.
the mic view. I think it's a direction at you and not at us, so like they don't pick up a lot of the questions that we ask.
Sorry?
Well, at least the way that you have the mic right now.
Yeah, I have to repeat that question. Yep. All right, so we are done for this week. Have a nice weekend. Don't forget you have to turn in the homework on Tuesday next week, and read ahead of me. There's a lot of stuff to read ahead. Huh? I forgot again. But surprisingly, most people are still here. I cannot really see any significant, absences.
Hey, you asked for questions, but you know what happened when I did all three questions.
Oh, that's fine. Those are all legitimate questions.
Professor, just letting you know, I haven't been feeling well all week, so I was trying to be as alert as I